Okay, today we're going to talk about some material from unit number 2, box C. Basically, we want to talk about what do we mean by the term powers. So we've talked a little bit about exponents. What exactly is a power? And the easiest way to tell you what a power is to just show you an example of one. Okay? This thing right here, 6 to the exponent 4, that together is a power. Okay? A power consists of two things. It's got this large number here that we call the base. Okay? And it's got this small number up in the corner that we've talked about before called the exponent. So the exponent and the base together make up a power. And we've already talked about what that exponent means. What this power represents, of course, is repeated multiplication. So if I have 6 to the power of 4 here, this really means that I'm multiplying 6 by itself 4 times. 6 times 6 times 6 times 6. So we call this thing here a power of 6. Okay, because our base is 6. So if we had something like x with the exponent 4, this would be x to the power of 4. This would be a power of x. So we can express powers in 3 different forms. We have what we call exponential form, which is what I've shown up here. So another example might be something like 2 to the power of, I'll just use 3 here. Okay? If you can see that exponent, it's what we call exponential form. We can also take it and write it in what's called expanded form, which means showing all of the multiplication that is implied by that exponent. So 2 to the power of 3 is 2 times 2 times 2, 3 times. Oh, and I wrote a 3 instead of a 2. 2 times 2 times 2, obviously. And finally, we have what's called evaluated form, which means we take either our exponential form or expanded form, and we express it as a single number. So evaluated always just means express it as a single number, or express it as simply as you possibly can. So if we were to express this as a single number, 2 times 2 times 2, well, 2 times 2 is 4, times another 2 would give us 8. So 8 would be our evaluated form. Now our base can be a number, it can be a variable, or in some cases we can have a fraction as the base of our power. So we can have something like fraction 3 over 2, and we can put that to the exponent 3. We can still write this in expanded form. In expanded form, this is just going to be 3 over 2 times 3 over 2 times 3 over 2. And I've put the base in brackets here, and that's a good habit to get into, just to make it so, just so you're sort of noticing what exactly the base is in each of these things. So here, my base is that entire fraction, 3 over 2. So there it is in expanded form. If I was going to write this in evaluated form, well, I'm just going to follow the rules that I have for evaluating fractions. Okay? I'm going to do for multiplying fractions. I'm going to do my numerators multiplied by each other. 3 times 3 times 3 would give me 27. 2 times 2 times 2 gives me 8. So my evaluated form here is 27 over 8. We can also think about this question in another way. We have this 3 that's our exponent applies to everything that is inside these brackets. Okay, so we can think of having this 3 being an exponent on the 3 that's in our numerator, and the 3 being an exponent on the 2 that is in our denominator. So if we think about it that way, this is equivalent to 3 to the exponent 3 up in our numerator, and 2 to the exponent 3 down in our denominator. Then what's 3 to the exponent 3? Well, it's 3 times 3 times 3. What's 2 to the power of 3? Well, it's 2 times 2 times 2. And again, we get the same answer, 27 over 8. Okay? So whichever way you want to think about it, the answer is going to work out to be the same. So those are fractional bases. All right. The trickiest bases to work with are when your bases are a negative number. So what I mean by negative numbers, you might see something like this. Negative 3 to the power of 3. Okay. So what is our base here? What is the base in this power? Our base is negative 3. So this means negative 3 times negative 3 times negative 3. Okay? Where I've put brackets around our base just to let you know that that negative sign is part of the base here. So if we do negative 3 times negative 3, we get, well, negative times negative gives us positive 9. And then we multiply by negative 3 again. Positive times a negative gives us negative 27. Okay, so we've got 3 negative signs in there. We're going to get a negative as our answer. If you see something like this, okay, with no brackets, notice I've got brackets here around the negative 3. Here I don't have any brackets. In a case like this, without any brackets, you assume that this 2, this exponent, only applies to this first thing right here, just to the 3. So in a case like this, our base is not negative 3, but just 3. That negative sign isn't part of the base, unless there's those brackets around it. So this one, we would have this negative sign floating out front, and then our power here is kind of like this, 3 to the power of 2. So 3 to the power of 2 is 3 times 3. So our answer here is going to be negative 9. The 9 comes from the 3 times 3, and then we still have that negative sign floating out front. Now, if we saw something like this, what is our base in this case when we do have these brackets around it? Yeah, now our base is negative 3. So when we do our expansion, we get negative 3 times negative 3, which gives us positive 9, because it's negative times negative. Okay. And another rule of thumb to sort of remember is that if I have a negative base here, base is negative 3, if my exponent is even, okay, I will get an even number of negative signs when I do my expansion. My answer here is going to be positive. Up here, where I had an odd exponent, 3, I get an odd number of negative signs when I do my expansion. My answer is negative. Okay. So if I had something like -5 to the exponent 7, okay, is the final answer going to be negative or positive? Okay. Is my exponent odd or even, first off? It's odd, so when I do my expansion, am I going to have an odd number of even negative signs or an even number of negative signs? I'm going to have an odd number of negative signs, so is that going to give me a positive or a negative at the very end? It's going to give me a negative. So this will be negative something, and I don't even know what it is. Somebody could punch that into their calculator and find it. Okay? Okay, the last thing we need to talk about here is that our base can also be a variable, as I said before. So in this case, I've got 6x cubed. This is an example of a term. Okay? What I have here is I have a power x cubed, and I have this number out in front of it, which we call the coefficient. Okay. The only thing that's cubed here is that x. So if I were to write this in expanded form, my x is cubed, so I'm going to have x times x times x, and that 6 just stays out front as a coefficient. So in this case, that 3 doesn't apply to that 6 because the 6 isn't part of the base. Okay? So I should write over here that the base is x. Now, if I had something like 6x cubed, like this, what's my base in this case? Not just the 6. Yeah, that whole thing that's inside the brackets there is my base. So my base is 6x. So if I were to write this in expanded form, I would write my whole base, 6x times 6x times 6x. And I need it multiplied by itself 3 times. Okay? Yes? Go ahead. All right, and that's where we're going to stop.